Okay, so let this is x, right? So I would say x square root, I'm going to say this is u. So if I do that, you know that du over dx is equal to 1 divided by 2 square root of x. So from here you can subject dx, which is 2 times square root of x du. Okay, so this is my first equation, right? Then what I have is square root of x plus 1, right? So okay, so now what I'm going to do, integration square root of x plus 1 dx is what I have, right? So it's going to be u here, right? So it's going to be u squared plus 1, right? So what is dx here now? Dx here is so dx here is 2 square root of x du. So this is nothing but u, right? So that will tell you that this is 2u squared divided by 1 plus u squared, right, du. Okay, so now after what is after? Right, so what is after? Now integration, I'm going to take 2 out. Then what I'm going to do is I'm going to make 1 plus u squared. You use this trick, right? And then divide by, you have 1 plus u squared. So there is an extra 1 you introduced, you minus it, right? So then you get 2 times integration of 1 du minus integration 1 divided by 1 plus u squared, right, du. Okay, so do it consciously, right? Then what is this one over here, right? So what is this one over here? Isn't it tan inverse u? Am I right? Yep. So I get the answer 2 times, you get u here minus tan inverse u, right? So I can put plus k over here. So finally it would be 2 square root of x minus tan inverse square root of x plus k.
So it's the numerator denominator by
No. Just Aman, tell me how did you do that?
Okay.
I used perfect squares, so I changed 1 plus sine x to 1 minus sine x on cos squared x. Then I broke it up into 1 divided by cos squared x minus sine x divided by cos squared x, because 1 over cos squared x is sec squared x, and the integral of that is tan x. And sine x on cos squared x, you can use substitution to get 1 on u squared. And once you integrate that, you can get back tan x minus 1 on cos x plus k. and 1 on cos x is sec x.
Okay. So let me do what Aman said. What Aman did. Aman is saying do this 1 minus sin x divided by 1 minus sin squared x, right? This is what Aman did. Okay. Aman multiply this by 1 minus sin x. Right? Multiply this by 1 minus sin x. So then this is nothing but 1 minus sin x divided by cos squared x dx. Okay. So let me know when if I'm wrong. Then here, then he did this. So integration 1 divided by cos squared x dx minus, here you get sin x divided by cos squared x dx. So then he is saying that this is nothing but sec squared x dx minus. Okay. So now what is the substitution you did, Aman?
I substitute u equals cos x.
Okay, u is equal to cos x. So what he did, u is equal to cos x. So if u is equal to cos x, du is equal to, right, du is equal to minus sin x dx, right? So then what we can do here, you get sin x here, then u is equal to cos x, so it's going to be u squared here. Then dx is equal to, oh, I need dx, right? Sorry, I need dx. So dx is equal to du divided by minus sin x, right? So these two gone, right? Those two gone. Then you get this is going to be tan x, right? Tan x minus becomes plus, right? Minus becomes plus. This is going to be 1 divided by u squared du. Okay, so that would be tan x minus, right, minus u minus 3, right? So minus 3 plus 1 minus 3 plus 1 what? Minus 3 plus 1 minus 2, right? So it's going to be u minus 2 divided by 2, right? Plus k. Am I right, Aman?
Isn't it u to the power of negative 1 and 1?
Oh, minus 2, right? Okay. Yeah. So it's going to be negative 1, 1. Right? Yeah. So u is equal to cos x. So final answer would be tan x minus 1 divided by u is equal to cos x, right? Cos x plus k. Yep. So how Anuk, is there any other method you did?
No, that's exactly what I did.
Oh, that's exactly what you did. Okay, so this is what exactly you did, right? Okay. Then try this question. Try that question. Okay, let's do this. 1 divided by 1 plus cos x, right? Okay, let me do this in this way. What if I multiply this by 1 minus cos x and this by 1 minus cos x? Then I get what? Divide by sin square x dx, right? Yeah. Now, so it's seemingly you can do this. Seemingly you can do this. But if you think about this guy, right? That guy is 1 divided by sin squared is cosec squared x. Right? Can you do that? There is no base case, right? Then if you extend that knowledge into here furthermore, you know this identity, right? Cos x squared x is equal to 1 plus cos squared x. Okay? You know that. Now, if you think in that line, this would be integration 1 plus that. Okay? Right? Now again, you are stuck, right? Here. Integration cos squared x, we don't know. So now you can see we are stuck. In this question we are stuck. But a similar question here, sin 1, you could do. Cos 1, simple tweaking, right, to the problem. Okay, so then we have to do something, right? Okay. So 1 plus cos x. So we will try another method to do this business, right? Okay, so we'll do this. You know cos x can be written as okay, cos x can be written as cos squared x divided by 2 minus 1. 2. Double angle theory, right? Double angle theory, right? So if you have 2x here, that means this is x here. X, if you have x here, you have x divided by 2 there, right? So now you can rearrange here. You can say cos x plus 1 is equal to 2 times cos squared x divided by 2. Okay, we can try that, right? So here, now what we are going to do, integration 1 divided by, I'm going to put 2 here, you get cos squared x divided by 2. Cos squared x divided by 2 dx. Okay, so that would be sec squared x divided by 2 dx, right? Now you can take this one as u, right? So u is equal to x divided by 2. So du is equal to, okay, half times dx, right? So dx is equal to 2 du. So this would be half integration, right? So sec squared u dx is equal to 2 du. So du, I put du here and put 2 here. It's all gone. Answer would be what I'm doing. Answer would be right. Answer would be 10. That. Okay, so now you have to know these methodologies. Okay, you have to know these methodologies because these structures are coming in papers. Sometimes they will give you sin x, sometimes cos x. Next one is the next next one is the final variation that you need to think about. Integration, if you have 1 divided by 1 plus tan x. Okay, now think about it. Quickly, if you are done, let me know. Okay, let's try this one then. Okay, so you know that tan 2x is equal to 2 tan x divided by 1 minus tan squared x, right? Right? So we have tan x here. So tan x is equal to 2 tan x divided by 2 1 minus tan squared x divided by 2. See whether we can do it. Okay. So if you substitute that here, you get 1 minus tan squared x divided by 2 down divided by right 1 minus tan squared x divided by 2 plus 2 tan x divided by 2. Okay. Right. So now we can do one thing. I'm going to do this. Tan squared x divided by 2 minus 1. The whole thing divided by tan squared divided by 2 minus 2 tan x divided by 2 minus 1 dx here. Okay. So can you factorize it? So can you factorize it?
So
Uh-huh.
you could try, well, there's two ways you can go about it. You could try multiplying the numerator and denominator by 1 minus 10. And from there, when you have the identity tan 2x is equal to 2 tan x divided by 1 minus tan squared x, subject 1 minus tan squared x and sub that into the fraction.
1 minus tan squared x. What is 1 minus tan squared x?
So if you times the numerator and denominator by 1 minus tan x, you get 1 minus tan x divided by 1 minus tan squared, right?
Yeah.
And you can subject 1 minus tan squared x from the tan 2x identity.
Okay.
And after some simplification, I got up to x minus integration sec 2x, but I can't integrate that. Or alternately, you could try and times the numerator and denominator by cos x, and after some more simplification, like I got to the same problem where I didn't know how to integrate sec 2x.
Oh, okay.
So.
Okay. But here we stuck, right? So here we stuck. Okay, so we'll move on quickly. So what Anuk is saying, 1 divided by 1 plus tan x multiplied with 1 minus tan x and then 1 minus tan x, right? So then 1 minus tan x what you have here, so here 1 minus tan squared x. Okay, so then what you are saying?
Then from the identity, the tan compound, double angle formula, you can get that 1 minus tan squared is 2 tan x divided by tan 2x. Yeah.
How come?
Because of the double angle, so when you have the tan 2x double angle formula, you have it's 2 tan x divided by 1 minus tan squared x. So when you subject 1 minus
tan x divided by 1 minus tan squared x, right?
Yeah. And you can subject 1 minus tan squared x and sub
okay.
and
So
then
you're asking me to do that, right? So it's going to be 2 tan x divided by tan 2x, then whole thing divided by 1 minus tan squared x. That? Oh no. Other way
Dude,
around.
I'm real good with that. So.
Say it again. What?
sorry. So on the compound angle formula, if you subject 1 minus tan squared x, that would be 2 tan x divided by tan 2x. So it would be tan 2x times by 1 minus tan x. Yeah.
That?
And then, yeah.
Then?
So then when you would multiply them together and split the fraction. Yeah. And 1 second.
You have a simplification problem somewhere.
Oh, wait 1 second. I took the, well, so on the, so tan 2x you can simplify, wait 1 second.
No, it's not going anywhere.
That one. Or alternatively, you could try on the original integral times the numerator and denominator by.
So you are not going anywhere. So we tried everything, right? So we tried this method, right? So this is Anuk's method, and we tried this substitution method, right? So it didn't work, right? So that means no analytical solution. But this question is 2009 some VCE paper, right? This question, right? So they will give you 1 divided by 1 plus cos. So they can give you sine as well. But tan, you can see problematic down the road. Okay? So you can't do that business. Okie dokie. Now, we will go into our basic thing here, right? The lesson today, vector function. This is very important, right? So we'll understand vector is v vector is equal to xi plus yj, right? This is called unidirectional vector. Write the note, okay, because I can't send it to you. Unidirectional vector, right? Why? Because why? Because if you have x and y, or not x and y, if you have I and j, so it would be like this, right? So it's unidirectional. You can see it's one directional, right? Now vector function. Vector as a function, understand it. So you are going to write v as a function of time here. What do you mean by that? That means it is changing with time, right? So if v is a function of time, so this x is function of time, right? Y is a function of time, right? So this is called multidirectional. Multidirectional vector. Okay. Now how do you visualize that, right? So how do you visualize that? This is how you have to do. I and j. Suppose this vector is here, v0. v0 vector is here, right? Then this is the vector v1. That means t is equal to 1. The vector is there. Why? Because changing, right? You can see this x value and y value is changing with time, right? So when v is equal to, t is equal to 2, v2 looks like this, right? That looks like this. Now you can see, if you connect this here, right, that is called trajectory. Trajectory of the vector function. Right? Trajectory of the vector function. Right? This function is a spatially dependent function. Understand this? This trajectory is a spatially dependent function. This trajectory is a spatially dependent function. Spatially dependent function means that should be a function of x, y, z, right? X, y, z. So that's all about the vector function. That's all about the vector function. Now, okay, think about, you have r as a function of time, where you have x here as a function of time, I, then you have y as a function of time, right? Then what if you do time derivative here? What if you do time derivative? And this is your position vector. position vector function. Position vector function. Okay. Now if you do that, here you get ddx of not x, ddt of x of ti plus ddt of y of tj. Right? It should make sense now. Right? So this is going to be velocity as a function of time. Should make sense. Right? So we are doing the derivative. So now this becomes velocity, right? As a function of time. What do you mean by this? And what do you mean by this? ddt of x, what do you mean by that? ddx of y, what do you mean by that? So understand ddt of x is the displacement, right? That is velocity in x direction, x directional velocity. Velocity in x direction. So ddt of y t would be the velocity but in y direction. Okay, so you have to understand that. So now you can say right, so vt is vx t I plus vy t j. Okay, so similarly you can say acceleration as a function of time, right? That would be d squared dt squared of r of function t, and that would be second derivative, right, of x of t I plus the second derivative here of y of t and j. So if you do that, this is going to be a but in x direction as a function of time, plus this is going to be a in y direction as a function of time, and that is j. So this is in general, it's a. Okay, write it down. Definitely this is a question in paper number 1 and paper number 2. Definitely this is a question. Paper number 2, big question. You get a short answer question from here. Okay, so we're done, right? Yeah, I hope it is done, right? Now, let's think about this, right? Now think, So we discuss about r as a function of time, that is x t I vector plus y t j vector. Okay. Now what is the meaning of this one? Consider t is equal to 0. T is equal to 0, you get r0 and you get x0 in I direction, you get y0 in j direction. So that means, right? So that means, right? That means you have x0 in this direction, y0 in this direction, and this is your r of 0. Okay. Now when t is equal to 1, you get r of 1, x of 1, y of 1, right? So that would be, that can be like this, right? So this can be y of 1, this can be x of 1, right? This, that is your r of 1, right? So you can understand now they are time dependent functions, right? Time dependent functions. And right, so if you draw that in the same plot, it would be like this, right? It would be like that. Two different, right? So what has happened finally, this position is changed to this position within a second or within one time unit. Okay, so that means this has moved, like not necessarily straight line, right? It has moved something like that, or something, somehow it has changed, right? So that line is the trajectory. That line is the trajectory. Okay. So yeah, that's all about that bit, right? Any questions? No questions. Okay, so then we can say r of t, x of t, I plus y of t, j, and velocity t can be written as x dot t, that notation also valid here, right? Y dot tj, right? So acceleration as a function of time can be written as x double dot t plus y double dot tj. Okay, so those are valid things that you have to understand really. Okay, so these are, yeah, so these are nothing but velocity in y direction as a function of time. This is nothing but acceleration in y direction as a function of time, right? So this is nothing but velocity in x direction as a function of time, right? So acceleration in x direction as a function of time. Okay, that's the thing. Okay, okay. Next question. Okay, so now we are done with the theory. Okay, we'll discuss the question. Let R of t is equal to 2 minus ti plus 3 plus t squared j, right? 2 plus t squared j. Find the Cartesian equation. Find the Cartesian equation. Find the Cartesian equation, right? So the meaning of this Cartesian equation, right? The meaning of this Cartesian equation is the equation of the trajectory. Equation of the trajectory is what you have to find here. Okay. Now, how to do this? You know, this one should be x of t, right? This should be y of t, right? Right. So usually you take this as x, this as y, knowing that x of t is x, y of t is y, right? Then you write down here x is 2 minus t, y is 3 plus t squared. So this is your first equation and this is your second equation. Okay. Then what you do, from the first equation you subject t. If you subject t, you get 2 minus x, right? And then put this one in here. So you get y is equal to 3 plus t squared. T is equal to 2 minus x squared, right? So answer would be y is equal to, answer would be 7 plus x squared minus 4x, right? Now I told you that this is the answer, right? So this is the answer. This is the trajectory, right? And if you look at this clearly, this is a function of y. Y is a function of x, right? So that's why I told you trajectory is a spatially dependent function. Trajectory is a spatially dependent function. Okay. What is idea? Okay, just write it down. Write it down, no, do whatever, get screenshots or whatever. You know, I don't mind you have these things, you don't have these things in the book but in your head, right? That's all we need. You guys are experienced now. You guys have done this exam, right? So you know their expectation, right? So your life is done in 2 hours. Right? I'm telling every time, your life is done in 2 hours. The best preparation is do papers as much as you can. That's the best preparation. We don't know what kind of a snake we'll get, but that's the best preparation. Some people don't do it, right? It's just they finish the syllabus like at the end of the year. What? After that, what? Disaster. Okay. So, any questions here? It's all good? Okay. It's all good. Moving on. Next question. Okay, let's do this one as well. R of t is equal to 1 minus cos ti plus sin tj. Okay, now find the thing, right? So to do that, this is your x, right? This is your y. So you have to know that is x as a function of time, okay? So you write your x would be, separately you do that, right? 1 minus cos t here, and y is equal to what? Sin t here. Okay? So now from here, what you do, you are going to subject cos t. If you subject cos t, you get 1 minus x. So from here, sin t is equal to y, right? So from here, we know that sin squared t plus cos squared t. So we have to take a known relation, right? So sin squared is y squared plus cos squared is going to be 1 minus x squared is equal to 1, right? So answer would be y squared plus x squared, right, minus 2x is equal to 0. So that's the equation of the trajectory. Okay, that's all good. Now next question. R of t is equal to 1 minus cos of 1 minus let's say 1 minus 2 cos of t I plus 3 sin t of j. Okay, do that. So you get the answer here. So it should be right. Right. So now this one, if you want, you can write x minus 1 divided by 2 squared plus y squared divided by 9 is equal to 1, right? And if you have that, what is this? So essentially this is x minus 1 squared divided by 4 plus y squared divided by 9 is equal to 1, right? So, and that is again x minus 1 squared divided by 4 plus y minus 0 squared divided by 9 is equal to 1. And this is the equation of what? Ellipse. It's the equation of ellipse, right? So what would be the center? Center would be 1 0, right? 1 0. So it would be like 1 0 is the center here, right? So it's an egg like, it's an egg, right? So it's an egg like it's an egg like that, right? Yeah. Yeah, and you have to understand from here to here distance would be 2. From here to here distance also 2. Right? From here to here distance would be 3. From here to here distance would be 3. How come? Because 2 is coming from here, right? 3 is coming from here. Right? So it's an ellipse. Right? Yeah. So I hope it is clear, right? Now, what is the big picture here? Okay. Big picture would be this. You got R of t, right? I plus j. You got R of t, right? Now, when you plot that, it is ellipse, right? It's ellipse like that, right? So that tells you from here, this would be your R of 0. This can be your R of 1. Those positions, right? This can be your R of 3. This can be your R of 4. Right? So likewise, when you are increasing your time from 0 to a certain value, right? The position is changing from this position to this position to that position to this position. So it goes around a ellipse, and that is called the trajectory of R of t. So this is called the trajectory. Okay. Okay, any questions? Guys, no questions? Okay. Can you hear me, guys? Yeah? Okay.
Yeah, we can hear you.
Okay. So that's the big picture, okay? So now, if you go to this, think about this. R of t is equal to 2 sec ti plus tan tj. Two sec ti plus tan tj. Okay, find the trajectory now. Quick. Okay. Yeah, so it's going to be, let's see. We get sec squared t 1 plus tan squared t, right? So it's going to be x squared divided by 4 minus this is y, right? Y squared is equal to 1, so it's going to be 1 here, right? Right. So what this would be then? What is this? What is that? Oh. You know that. Is hyperbola. Right. You know that, right? So what we had here, it's a hyperbola. If you have other way around, x squared divided by a squared plus y squared divided by b squared is equal to 1. That's an ellipse, right? That's an ellipse. So the only difference is this, right? Over that. Right. Okay. Then, you know, if a is equal to 1, not 1 actually, a is equal to b. If a is equal to b, then this will be x squared divided by a squared plus y squared divided by a squared is equal to 1, right? Then cross multiply, so you get x squared plus y squared is equal to a squared. So that becomes circle, right? So ellipse becomes circle under this condition, right? So yeah, so you understand that bit, right? Now how to plot this? Right, how to plot this? So x is starting from 2, right? Because you have here x is starting from 2, right? 2 here, minus 2 here, right? Like that. Then should be something like this, right? Right. So this line would be y is equal to x divided by 2. That you know how to extract from the hyperbolic equation, right? This is equal to y is equal to minus x divided by 2. Okay. It's like that. So that would be the trajectory of that given vector function, right? Trajectory, right? So the basic knowledge about hyperbola and ellipse and circles, you know, they are very important, and I think we discussed how to get the the asymptote conditions for hyperbolas, right? I proved it, if you can remember. I proved it, right? Yeah. So again, if you want to remember that, okay, so this formula would be for the ellipse, right? So it's going to be this, right? So suppose you get here y squared divided by b squared minus x squared divided by a squared is equal to 1. So how to do this one, right? So you remember y squared divided by b squared, you bring the thing into the other side, so it's going to be 1 minus x squared divided by a squared, right? Right. Okay. So then you subject y squared, right? So you subject y squared, that would be b squared minus b squared x squared divided by a squared, right? Right. Then what we do? Right? Then what we do? So we take b squared x squared divided by a squared out, right? So then you get if I get b squared, so you get a squared divided by x squared here, right? Minus 1, right? Right? Yeah. Okay, hold on.
Isn't it 1 plus x squared on a squared in the first step?
Yeah. 1 plus where? Oh, I see. Here, right? Yeah. Plus, right? Yep. Then, when x goes to, when x goes to infinity, right? What will happen? When x goes to infinity, this goes to 0, right? Then under that condition, x goes to infinity condition, y squared is b squared divided by a squared x squared, right? So y is equal to plus and minus b divided by a x. So those are the asymptote conditions, right? So I think that is what we have obtained here, right? Yeah, x divided by 2. So these things, right? So that should be done in back of your mind to get the asymptote conditions, right? Okay. Okay, let's see what else we have to finish. Okay. Yeah, it's pretty much I discussed all the theory, right? Pretty much I discussed all the theory, right? So how the position vector can be transformed into velocity and acceleration, that already I discussed. It's just a matter of taking the ddt, right? Right. Okay. Okay, so let's think about this. Okay. Okay, let's think about this now. Displacement vector. Displacement vector, right? Displacement vector is r of t. Okay, so displacement vector is r of t. This, right? Right, this is your displacement vector, right? Now, if you need to find out the distance when t is equal to t, right? You understand displacement is a vector quantity, right? So the shortest distance is distance, right? Now, for example, this is a point, so you are going to b point, right? Then displacement would be this. This is displacement. Shortest distance is the displacement. Distance is the white color path, right? And displacement is a vector. Distance is a scalar. Okay. So, how to find the distance? That would be the mod of this one, right? That is the distance. So how do you calculate the mod of that one? You know that square of this one time plus y of t square of this one square root, right? So it's very similar to our vector. If you have a vector p vector as xi plus yj, right? Xi plus yj. So what you do is, what is p vector magnitude? Now, what is p vector magnitude? P vector magnitude, you remember? P vector dot with p vector square root. This is vector lesson, right? So that would be x squared plus y squared square root. That's how you got it, right? Even in complex numbers, you have these things, right? Even in complex numbers, right? So in the distance, you did the same thing here. Okay, so that's how you convert a vector into a scalar, right? Vector into a scalar, right? So you can have a question like this: velocity is a vector, function of time, right? So that means here you have function of time here, right? Plus fg function of time here. But you understand this velocity is a vector. So if you need to find the speed, so this is a velocity, right? Velocity. If you need to find the speed, right? So what do you do? Speed is this, but at t is equal to t, guys, okay? So at t is equal to t, that would be ft square plus gt square square root, right? If you need to find the velocity t at t is equal to 10 specific, right? So it's f10 like that. And that is your speed. Speed is a scalar. Okay. You got what I'm saying, guys? Yep. Then we discussed this, but there is a specific name in the book. If you check, we call it what do you call that? Vector calculus. Vector calculus is a university subject as well. Okay, vector calculus. Vector calculus is when the position vector is given to you, right? So this is called position vector. Position vector. What do you mean by that? Position vector means in here I and j, this is your position, right? So we are defining this position, a position from O. So it's a position vector. It has a specific direction along that line, right? So we call it position vector, or we can say displacement vector. or we can say displacement vector, right? Doesn't matter. Okay. Now, if the position vector is given to you, if you need to find the velocity, as I told you before, right? So it's just a matter of doing this, right? And if you need to find the acceleration, it's just a matter of doing this or that. So all of these is called vector calculus. You know, vector calculus. Right? Very easy, right? Very easy. Specialist is very easy. Then, okay. Now think about this example. Question. Consider, let's think, okay. Where m is a constant. Okay. Where m is a constant, right? So now, what is x of t here? F of x of t, x means x, right? X means displacement, right? So this is position vector, in x direction, or displacement or x displacement, I would say. Position vector in x direction or x displacement. Okay. So then, so what is the meaning of this one then? That would be this, right? Like that, right? So what is this one here? This one here is velocity as a function of x, as a function of t, but in x direction. Velocity in x direction, right? ddt of y is velocity in y direction, right? So ultimately this is nothing but acceleration as a function of time in x direction. Okay. Okay. So any question? No question, right? Okay. So now you have acceleration there, right? So now we can do this. So you have this, right? So this is a function of t, right? So it's going to be phi divided by m, right? So suppose you need to find t. So you take the upside down, right? You take the reciprocal, right? So like this. Okay. M divided by 5, right? And then you are going to cross multiply, right? M divided by 5. Yeah. M divided by 5. This is going to be d what? D squared x. Right. Then what you have to do is you know that you have to introduce double integral here, double integral here, right? After that it would be integration, right? Integration and differentiation only, right? So when you do that, you get t here, right? Then you get m divided by 5, because m is a constant, as I said, right? 5 is a constant. It's just an example, right? So it's just double integration of that one, right? Double integration of that one. Okay. So you can get questions like that, but after a certain point, right? After a certain point, it would be a it would be a it would be integration calculus, right? Right. So yeah. Okay. Right. So few questions. The rest of the, so this lesson is done. Okay. So we will do homework questions and then we'll discuss how to use those things. Pretty easy. Okay. Question. Consider r of a function t is equal to, okay, f of t, maybe f a of t I plus g of t b j, right? Or r of b is f of b function of t I plus g of b function of tj. Okay, right? So something like this. Okay, so two position vectors are given to you. Two position vectors are given to you, right? If velocities of a comma b, if velocities of a comma b are equal at t is equal to lambda, right? Then what? Right? So this is what we are going to discuss. So if velocities are equal, if the positions are given to you, so you take the velocities, right? You take the velocities, right? So velocity would be r of a as a function of t, right, is equal to ddt of t r of b at that point, right? Now, but this is evaluated at t is equal to lambda. Okay, you guys feel what I'm saying, right? Yeah. So this is what this is how you approach the questions, right? Vector function thing is very easy. It's a function changing time to time. Then when the location is changing time to time, there is a trajectory. That is the idea you should have, right? So sometimes they give you questions to find the trajectory. Sometimes they give you application type of questions so that these velocities, accelerations and other business are involving, right? So it's just a matter of visualizing the problem and then sort of equating whatever the things given. That's very easy, right? Theory wise, this is it. But when it comes to a question, That means we have to sort of put that question into your head and sort of do something and connect with what you know. Okay. So yeah, we discuss vectors as a function of time, right? Now, so we call it vector functions. So we discuss just as a function of time only, right? So can it be a function of x over y or z? Can it be x over y or z? So those things you have to understand, right? So those things you have to understand. Typically no, because in almost all the cases you get vectors as a function of time, because time to time only the position changing, right? One position is changing time to time. So yeah, so okay, any questions?